earlier class, we have already seen what is a stack, how you can implement stack using arrays. Today, we'll be seeing what is a queue. As you all know, queue is also a linear data structure. It's a linear data structure. We all know that in the stack, we'll be using LIFO mechanism, but in the queue, you will be using FIFO mechanism. That is first in, first out. First in, first out. So suppose you can take the example of you are standing in a queue from some ticket reservations. Okay. So whoever first tries to get the ticket, that person will be quitted outside first, right? The last person will not be considered. The first person will be considered first. So that is the mechanism you'll be following here. What I mean is, whenever I insert some element in the first, that is the element which will be removed first. Okay. So you will be performing insertion at one end, that is called as rear, and deletion you will be performing at another end called as front end. Okay. So the operation of inserting an element into queue is called as enqueue, and the operation of deletion is called as dequeue. Okay. As you all remember, in the stack, you will be performing the insertion and deletion only at one end, that is called as stop. But in this is for stack, okay? But for queue, you will be using the FIFO mechanism, that is first in, first out, and I'll be performing insertion at one end, that is rear end, and deletion will be performed. Then deletion operation is called as dequeue, and that will be performed as front end. Okay? Let me suppose that this is my queue. This is my queue, and here the front will be pointing to here, and rear will be pointing to here. Okay. If some n minus 1 elements I have inserted, the size is n of this particular array, and the last index is n minus 1, and rear is pointing to this, means that the stack, the queue is full, not stack, the queue is full. Okay. Initially, when the queue is empty, the front and rear will be having the values of this one, minus 1. They'll be having the values of minus 1. Okay. Front and rear will be having values of minus 1. Okay. Front will be pointing to this, and rear will be pointing to the last index. That is what we can consider. You can also start the rear pointing to the left and front pointing to the right side also. It's our wish how we take it. But one thing you have to remember, whenever front value and rear value equals to minus 1, that indicates that queue is empty. Okay. So how you can implement queues? How you can implement queue is nothing but you can implement using two ways. One is using arrays, that is static memory allocation, and other is using linked list. This is dynamic memory allocation. And I forgot to say you one thing. So whenever you're performing enqueue, that is when you're inserting an element into the queue, what you have to check? Whether the queue is full or not, right? That's the condition you will be checking. You will be checking the overflow condition here. This indicates the queue is full. And when you're performing dequeue, that when you're performing deletion operation, you need to check for underflow condition. What is the meaning of underflow condition? That queue is empty. We are trying to delete from the queue which is empty. At that time, the underflow condition will rise. And when you are trying to insert an element when its queue is full, at that time, overflow condition will arise. So these are two conditions what you need to check when you're performing insertion and deletion. Okay.